Well, welcome back. In our last lesson, we learned how to prove that polygons and triangles in specific are congruent. And basically, we learned that we have to show that all three of the sides are congruent as well as all three of the angles are congruent. So we said that if all of the angles and if all of the sides are congruent, then the polygons or the triangles are congruent. In this lesson, we're going to learn that we don't need all of that information. We can actually prove that triangles are congruent with less information than that. So our first postulate is the side postulate. And basically it says that if you can prove that three sides are congruent, then the entire polygon is congruent to the other one. Okay, so it's called the side postulate. So here's an example of how we would use the side postulate. In this problem, we have a rectangle with a diagonal, and we're given that LM, the bottom side here, is congruent to NP, and that LP, which is the left side, is congruent to NM, which is the right side. So we have two of the sides of the triangles congruent. We want to prove that triangle LMN is congruent to triangle NPL. Well, we're going to start with our given statements. Our two given statements are that LM is congruent to NP and that LP is congruent to NM. So all we need, according to the side postulate, is that the third side here is congruent. Well, any segment or any side is congruent to itself. That's a side that they have in common. So we could say LN is congruent to itself, which is called the reflexive property. So now once we have that, we can say that all three sides are congruent. And let me just put in here a symbol on this line to show that it's congruent. Remember, we use these little hash marks up there. So all three sides are congruent by the side postulate. Now when you say your triangles are congruent, one thing I want to remind you of is the order of your letters makes a huge difference. When you write triangle LMN congruent to triangle, you have to write the order of the vertices that are corresponding. So vertex L corresponds to vertex N, vertex M corresponds to vertex P, and vertex N corresponds to vertex L. The order of those matters. Okay, so you have to be very, very careful when you're labeling your triangle sides. Here's one for you to try, very, very similar to the last one. Go ahead and pause the video and see if you can do this one on your own. All right, I hope you gave that a try. Let's take a look. This one's not too bad. Hopefully you were able to come up with this. Always start with your given information. So we know that side BC is congruent to side BF. And we also know that side CD is congruent to side FD. These are both the reasons for these are given. Both of those are given. So what do we need to prove now? We have two sides congruent. We need to get the third side congruent. Excuse me. So we're going to say that side BD is congruent to itself. And what would our reasoning be for that? How can we justify that? That was that reflexive property. Okay? So now we can say that triangle, now be very careful with your lettering here, triangle BCD, that was pretty sloppy, let me erase that. Triangle BCD is congruent to triangle, and that corresponds to BFD. And what is our reasoning for that? Well, we proved that all three sides were congruent, so that would be the side postulate. Our second postulate that we're going to be using is called side angle side. Now the thing that is unique in this postulate is that it says if two sides in the included angle, that's very, very important there that it's the included angle. So I just want to highlight that. It has to be the angle that's included between those two sides that we're talking about. So notice on these triangles that if you have two sides, it has to be the angle that's between the two sides. As long as you can prove that those three pieces of information are congruent, then you can conclude the triangles are congruent. All right? So let's take a look at this one. This problem says, what other information do you need to prove that triangle DEF is congruent to triangle FGD by side angle side? Well, in the diagram, they're giving us that EF is congruent to GD, okay? And we can prove that DF is congruent to itself by reflexive, right? So that would be easy enough to write that in our statement. But we need one other piece of information. And what piece of information would that be? We know this one's congruent to itself. So in order to have these two sides congruent and to prove this by side angle side, we would need to know that this angle right here is congruent to this angle right here. And we don't have that information, okay? So that's the piece of information that we would need to know. So we would need to know that angle EFD is congruent to angle GDF. Here's another one. What other information do you need to prove that triangle LEB is congruent to triangle BNL by side angle side? Well, here we are given a single angle that's equal. Okay, we can prove that LB is congruent to itself. Okay, that's easy enough to show as well, right here. LB is congruent to itself. So what piece of information would we need? Well, in order for this side and this angle to be used for side angle side, we would need to know that side LE, so segment LE, would have to be congruent to, now what are the order of the letters here? L and E corresponds to B and N. That's one way of looking at and making sure you get the right letters. LE would have to be congruent to BN, and we don't have that information, so we cannot conclude that. But if we had that information, then we could say that those triangles were congruent by side angle side. All right, how about the next one? It says, problem 3, identifying congruent triangles. Which of these will we use to prove they're congruent? Would we do side, 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 side angle side, or not enough information? Well, in letter A, if you look at these, we have a side, an included angle, and another side. And we have the same thing over here, so this one's definitely going to be side, angle, side. Letter B down here, we have side, angle, side here, but we don't have the included angle up here. Okay, that angle should be up here, so that one is not enough info. Okay, not enough. Over here for letter C, we have all three sides are marked as being congruent, so that would be side, side, side. And likewise, letter D is also side, side, side. Here's one for you to try. Go ahead and see if you can come up with the right reason for this one, and I'll tell you the answer when you get back. All right, this one is kind of tricky, I thought. Would you use side, 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 or side, angle, side to prove that the triangles are congruent? Well, we could use side, 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 right, because we're given that. Could we use side, angle, side? And the thing you have to look at for side, angle, side, this side has the 2 hash marks and the 3 hash marks, so the angle is between the sides that have 2 and 3 hash marks. But if you look at this one, it's not. It's between the one that has 2 hash marks and 1 hash mark. So you could not use side, angle, side. That could not be used, but we would definitely be able to use side, side, side. Okay, so be real careful on that. It looks like you could use either, but it's only side, side, side. All right, be sure to do your lesson check and have that ready to hand in at the beginning of the hour tomorrow. See you next time.